My name is Itianity Jude, and I would like to speak about mapping functions. A mapping function is simply the method used to locate a memory address within the cache. It is used when copying block from main memory to the lines in the cache, and it is used when trying to retrieve the data again. We have three kinds of mapping functions. The first one is direct, then associative, then we have set associative. So let me start with direct mapping. In direct mapping cache organization, the main memory is divided into blocks, whereas the cache is divided into lines. So the first block of data is mapped directly onto the first line of cache. The second line of main memory, the second line of the block in the main memory is mapped into the second line of the cache, and so is the third and the fourth. Now, if the cache has like 5 lines and the main memory has like 20 lines, meaning by the time the fifth block of the main memory has been mapped onto the cache is full. So what happens? The sixth line in the the sixth block in the main memory is mapped back onto the first line. So, and the seventh one is mapped onto the second. The process continues until all these blocks in the main memory have been mapped into the into the lines of the cache. And the memory address comprises of the tag, the line, and the word. The word is the same as the bit. Now, the second one is fully associative cache organization. In this one, the main memory is also divided into blocks, and the cache is divided into lines. So the first block of data in the main memory is free to be mapped anywhere within this memory here, anywhere within this line. It can be like WO, which is the first block, can even be mapped in this line. Then W1 can be mapped in this line. Then W3 can even be mapped in the first line. It is just free. The memory address comprises of the tag and the word, unlike in direct mapping. Then the third one and the last one is the KW set associative cache organization. Here, the main memory is still divided into blocks as usual, and the cache is divided into sets. Each set has the same number of lines. If a particular set has like 4 lines, we shall call it 4-way set associative cache organization. If it has 5 lines, it is 5-way set associative cache organization. So what happens here is that in the first block in the main memory, the first block is mapped into anywhere within this set 0. It can be mapped here, 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 or here, so long as it is in the first block. Then the second block is mapped anywhere within this set. It is somehow different from fully associative, because fully associative, it is mapped anywhere within the whole cache, but here it is mapped anywhere within the within the set. That's their main difference. Then we have the replacement algorithms, because you cannot just replace data anyhow. The CPU follows a particular algorithm, and they're the ones we want to look at. The first one is, we can start with the least recently used. This one is the most effective, and it replaces the block in the set that has been in the cache longest with no reference. The block has been there, but you have not been using it. Then we have first in, first out. First in, first out, this one replaces the block that has been in the cache longest. So meaning, if you go in first, you come out first. You go in last, you come out last. That is what they mean, and it is easily implemented as a round robin or circular buffer technique. Then the third one is least frequently used. Replace the block in the set that has experienced the fewest references when you have not used it, but it is just there. They first replace that one. Then the last one is random replacement. They stopped using this one, but it is also among the replacement algorithms. Here the lines of the cache are evicted randomly without any recognizable pattern. Thank you.